Today we're going to take a look at two weather components, and they both involve moisture in the air. One is going to be humidity, which is water going into the air, which takes an input of energy, which in this case is typically heat. And then we're going to take a look at dew point, which is water coming out of the air, which takes a loss in energy, which is again typically a loss in heat. You're going to be taking your notes back on the first page of the note packet. On the bottom here where it says humidity and dew point. Okay, all right, here we go. Humidity is a measure of the amount of water vapor that's in the air. Okay, the minimum amount would be 0%. There's no water in the air. It just really doesn't happen. And then the maximum amount that the air can hold is 100%. So if we go beyond 100%, we get precipitation or condensation or both. So we either get clouds and rain if we go above 100% humidity. All right. So we measure this with something called a hygrometer, and the terms we use to describe humidity are sticky, muggy, wet, steamy, dry. These are different terms depending on high or low humidity. So what does this mean when we talk about humidity? If we have high humidity, then that means we have low air pressure. We just talked about air pressure, so low air pressure means the weather's not going to be as good, so we're going to have cloudy skies, but we are going to have warmer weather in this case. Because we have more energy in the air, warmer air to hold all this moisture. But typically not your best weather with high humidity. With low humidity, we're going to have high air pressure, so air's not rising in this case, so we won't have clouds forming, so we have clear skies and cooler weather. Okay, so humidity can help us work on what the weather will be like depending on whether it's high or low. It's going to tell us whether or not it's going to rain, or whether it's not going to rain, and whether or not there'll be clouds based on the humidity. Okay, so how is this even possible that water can hang out in the air? Because water is actually lighter than air molecules, which is kind of mind-blowing, but these are tiny, tiny little particles of water in the air, and they weigh less than the air, so they can be suspended in the air. Okay, so the humidity is directly tied to the temperature of the air, and the higher the temperature, the more energy, the more heat energy that the air has to hold water. So if you look, you have a diagram on the bottom, a little table, and then some cylinders that have water in them. And we're going to start with cold air. So the capacity of that cylinder is 6 ounces. And the amount of water that is in that cylinder is also 6 ounces. So that means if its maximum capacity is 6 ounces and it's filled with 6 ounces of water, then the humidity is 100%. Okay. Now, if the air warms up slightly, let's say in the morning or after being cold at night, the capacity of that with warmer air now with cool air, which is warmer than cold, is going to be a larger capacity, so 9 ounces, but we still have the same amount of water, which is 6 ounces, which means now our relative humidity is going to be lower. So it's only 67% because we only have 2/3 of the possible amount of the capacity taken up. Now, if the air warms up further, say in the afternoon on the same day, then the capacity is going to grow to hold more water. So it goes up to 12 ounces. We still have 6 ounces, and our relative humidity will be lower, be 50%. Please make sure your table gets filled out there. You can kind of see the same thing going on the graph on the paper as well. The last thing we're going to talk about is dew point, and that's actually the dew point temperature. And this is the temperature at which condensation occurs. So that means it gets cold enough for air to not be able to hold on to as much moisture anymore. And so it releases that into the air. And how can we tell that's happening? There's a lot of different ways that we can tell that. Number one, there will be clouds. The word dew point tells you that the other way we can see that is dew, or in the winter we can see frost. Fog is another type of condensation that we can see, but all these are direct result of water coming out of the air because the air is losing heat energy and can't hold as much moisture. All right, today you're going to do an activity where you look at humidity and dew point. You're also going to do a lab. Well, I'm going to do the lab for you and give you the data so that you can measure humidity inside and outside and compare those. Good luck with that.